So with implicit differentiation, you need to take a look at what this denominator is. So this is saying that y is a function of x, and we're going to be taking the derivative with respect to x. So if we're taking the derivative of something with respect to x, then it depends on which variable we run into. If we run into x, then that would say take the derivative of x with respect to x, and that is a 1. dx over dx equals 1. If it says take the derivative with respect to x and you come across a y, then that's saying take the derivative, which we sometimes write as y prime. Okay, to begin with, in here we'll need to use the product rule. So take the derivative of y with respect to x, and you could either write the dy dx if you want, or y prime for short. So there's the derivative of the y function, and the tangent function is left alone. The product rule then says plus, leave the y alone, and take the derivative of tangent. And the derivative of tangent is secant squared. And then technically the chain rule says now take the derivative of this inner function, but that would be the derivative of x with respect to x. So multiplying by 1 isn't going to change the problem. Next, we've got the product rule over here, an x cubed and a y cubed. So I'll put the negative sign on the outside and then use brackets or parentheses. So the derivative for x cubed is going to be 3x squared. And again, take the derivative of x with respect to x, it's a 1, so multiply by 1. And then leave the y cubed alone, and we're halfway done with the product rule over here. Next, leave the x cubed alone, and take the derivative of y cubed. So that's going to be 3y squared. And then the chain rule says, okay, now take the derivative of this inner function, and the derivative of y with respect to x is y prime. And then onto the right side of the equation, so the derivative of sine is cosine. And like the last one, the chain rule would then say take the derivative of this y, which is y prime. So we've done the calculus part. Now we need to do algebra, because there is this term, and this term that all have y prime. So what we need to do is collect all three of those terms on one side, and these other terms need to move to the right hand side. So this one I'll move over here. So we've got this one, y prime and tangent. This one I'll subtract it, move it over to the left, so minus cosine of y times y prime. And then we've got this term, which because of this is a negative, x cubed 3y squared y prime. And then these two terms that don't have y prime, move them over to the right hand side. So this one would become positive when you move it over, 3x squared y cubed, and then subtract y. So I'll put these two guys together. Oh, that's a part of the secant. Never mind, y and secant squared of x. The next thing to do in order to solve for y prime is all of these terms have a y prime in them, so factor that out. And the right hand side stays the same for now. And one final step to solve for y prime is divide both sides by this thing. So we'll have y prime is equal to a fraction with this as the numerator, 3x squared y cubed minus y and secant squared of x. And then it's divided by all of this. I guess I might as well put that 3 in front. And there's y prime using implicit differentiation.